Okay, so at first, thanks for having me. My name is Alexandre Santos, and in the next 20 minutes, I'll be talking about the mistakes I made writing React and Redux applications. So to give you a little bit of context, my name is Alexandre, as I said. I'm 24 years old. I'm a full-stack software developer at PI Labs. We go to big corporations and bring them to the 21st century, who knows, to the 22nd. And I've been mostly working with JavaScript, some Python, and some PHP. So, why this talk, or what this talk is about? I've been writing React and Redux applications for the last 3 years, and as you might understand, I've made lots of mistakes. I've got some lessons from them. I've used lots of tools, tried lots of approaches. Some of them worked, some of them didn't work. And that's what this talk is about. So I'm going to be showing you the mistakes I made and a possible solution. So I'm not presenting like the solution, because we know in software that doesn't exist, but I'm going to present a possible solution. So the objective of this is that I can show you clearly my mistakes, so you can focus on writing code, reliable code, great code, so you can ship features instead of doing refactoring and rewrites. So, before we start, like lifting ends, I would like to know how many of you have heard about React or Redux. Great. And how many of you have worked with those tools? Okay. Less. Okay. So, the cool thing that you heard of it. So, React is a declarative component-based front-end library. It's backed by Facebook. It has this thing of running everywhere because now you can use React in AR and native in web. It is functional, so it has a functional programming approach, and it can be used embedded or from scratch, so you can build a mobile app with React. Or no, you can embed it in other apps. And one of the great advantages is that it has a very little API, so it's very easy to kickstart. And Redux is a state container. It's also known by its functional approach, so it provides you immutability and one single way of mutating your data. So one of their big selling points is that they provide you a single flow for you to change your data. So you imagine you send an event, it goes all through the same flow, and you have reducers that are the objects that know how to change your state. Redux tries to be the single source of truth for your application, so you get all your state there. And do you know how many times we started building our apps and we thought, okay, I need this, but in the end we handled with this? So that's what I call like trying to componentize too soon. So imagine we have this button, and I want this button to present some text. And at first I have my button and I just pass texting. But then I start thinking, okay, wouldn't it be cool if I can do some tricks with this text? So I create this text component. I put it inside button. So now I have a component that I can use to do things to my text. And then we start thinking, okay, but wouldn't it be cool if we start highlighting some words and then we create a word component? Oh, amazing. And then we get crazy and we are like, okay, let's create a letter component. And we get to this point where you have lots of components, and that will probably not going to be reused because it was us thinking that they will be so cool and everybody will use them, and it just makes no sense. So here I would like to refer you aren't going to need it. So from Martin Fowler, he says, try to build, just like do the simplest thing that can possibly work, and try to build functionality that you need, not functionality to predict the future. So my lesson here is like, please do not try to predict the future, simplify. If you ever think, okay, I have this logic somewhere, let's reuse it, you extract it, and the lesson here is, okay, if you need a button with text, please do a button with text. In the future, if you need more, do more. And for the second lesson, okay, so this is a lesson I taught you, like not try to componentize too soon and create company as needed. And for the second lesson, I would like to talk about that component we have. And we start saying, oh, let's add one more prop, because this component already does everything. We just add one prop, and then this component can change its behavior. And it looks cool. But we all know what's going to happen when we just do the one more whatever thing. Just one more drink, and we know how we'll end up in the morning. So to this, I called it add one more prop, as I said, and imagine we have this button. So this is a kind of simple button. So we have a button that has one style, one single style. But then our designer comes to us and says, okay, let's create an alternative style for the button. And what do you think? Okay, I already have my button, I will just customize it. So I'll pass a flag in this case it's alternative. And if it is alternative, I render the alternative style. If it's not, I render the default style. And it looks pretty cool though. This is one prop, it's okay. So, but then our button at the moment has two props. But then the designer comes and says, okay, there's this pop-up where you have to use the button differently. There's this menu where the buttons are differently. There's this sidebar, and you end up with this. So lots of components, lots of flags, and now your button has this thing that it was supposed to be a simple button, but now it is a button that knows that your app has a menu, has a card, has a sidebar, and then your components knows about lots of things. So I call this the props hell, because people keep passing props in, and there comes a moment where this is unmaintainable. So the lesson here is, please don't pass lots of flags to components, or at least pass the flags that are meaningful to the components. And think about the open-close principle. So the open-close principle, for those of you that haven't heard of it, it's a principle from Solid, from the principle of software design, where they say you have to build classes or components thinking about people using them and being able to extend it without modifying the file, the inner code. So here I have the button partially redesigned to support people, support the initial functionality, and support people using it from the outset and customizing it without having to change its code. So here I give the opportunity for people to pass custom styles so they can override the styles of the button. And I also pass this props so people can send more props to the button than what it was really designed for at first. So with this, to create the alternative button, or the zillion numbers of buttons you want to create, you'll just have to do this. So you create your alternative button, you use the logic from button that was already implemented, and then you can personalize style, you can send props like on click that weren't supposed to be on the primary button. So, and there's lots of ways. So here it's the two implementations, and there's lots of ways. So don't do the add one more prop. Please remember the big cup and the morning after. Try to add props that have meaning for the button. So think, does this button needs to know that there is a menu, there is a sidebar, there is whatever? Think in extending it without having to change the file. So if you have this thing that's used everywhere, that every time you want to use it, you have to go to the file and edit it, that's probably going to break some time because you changed that button, and then you broke at the same time the other in the footer. Yeah, that's complicated. And two things. Use children props and use render props. So these two, they both would give a talk of their own, but please Google it if you're interested. And because they provide even more composability than what I showed. So to the next thing. The point number 3 I have here is one of the biggest mistakes people do and start using Redux. That is bad Redux store planning. So imagine we have this to-do app, and we have one API, and we want to connect to the server and get all our to-dos through an API. And okay, our API just gives us an array, and you think, okay, I'll store it in an array. And then we want to give the user the possibility to select one of the to-dos. Imagine that is the to-do that is edited. And it all makes sense. Like now we have a to-do, it's an array, so we can loop through the array and render all the to-dos. But then, how, you're probably looking at this, you'll probably think, okay, but then you have redundant information, because you have it and you select the to-do, and how are you going to find the to-do with the ID number 3? Here you know it's the last one, but if there were 100, it would be complicated, and you will have performance problem, because you have to loop through them, you have to find them, and that would be a problem. So the lesson to get from this was to think state as a database. So when you're designing your state, please think of it as a database, because you're going to use it as a database. You're going to look at your state and think, oh, I want to get the to-do with ID number 3. And if you have to do 50 iterations of a for each to get that to-do, it will be kind of complicated. So here my proposed solution will be, can be more, but here you store your to-dos, and you store them by indexes. So thinking store as a database, when you design a database, you always think about the indexes. So if we're going to try to access to-dos by ID, you can store them by ID. And then all the other parts of your states that reference to-dos, reference them by ID. So here the selected, as you can see, it's the number 1. So with this, we can go to the to-dos by ID number 1, and we get the to-do we want. And now you might be thinking, oh, but then how are you going to loop through this object, that is a map of JavaScript objects, to render all the to-dos? You just have to go through all IDs, and as the all IDs exist, you can have IDs ordered. Imagine you have IDs ordered by created date or so. You can loop through them and go to your store and have, okay, get the to-do with the ID number 0, 1, 2, and then you can render your list. So, just to recap, like, try to avoid redundancy. Try to not store lists as arrays if you're planning to access them later, and try not to disregard indexes. So this all can be resumed in think of your store as a database. And then to introduce the next point. The next point is like coupling data, like your data model with UI. So I used to say that normally I do with the data model and the UI what I do with my mom and my girlfriend. That is, don't keep them together, because you're going to have problems if you keep them together. So, to this, I'll have like the mistake here, the bad example. Imagine you're trying to implement this Gmail top bar where you have multiple accounts you can be signed in, and you are implementing the top bar, so you think, okay, I want to share this state with the app, so I create the top bar in this. And then you create this change user. There's that button on the top right where you can change through your different accounts. And then you think, okay, it makes sense if I'm going to render my users here, to get my users and store them here. And yeah, it is cool, it works, it does what is expected, it makes sense now. But then, the next day, you have to implement the footer of your app. And then you start thinking, okay, I have my footer, and I want to say hi to my user. And I already have this information. So, what will I do? I will just access it. So, in my footer, I'm accessing top bar, change users with not valid ID, just for the example, and the email. So now you have your footer accessing data that is supposed to be for the top bar. And yeah, that is a problem because you're going to change it and it's going to break. So keep your UI and data decoupled and avoid nesting, because we're in JavaScript, and you know, if you have lots of nesting in your application, you'll have this common error that is you can't get property X of undefined. It always happens. And the redesign of this store, when possible redesign, would be to keep the users by ID, with all IDs, as I said in the previous example, and then have, if you really need to share the state of the top bar with your old application, just create an index for the top bar and have it separately. So and now you have your footer where you can say, okay, in my footer I want to get the user's email, so I just do this. And here you might be thinking, I'm going to talk about it later. So don't mix the UI state with data, have an almost flat store if you can with references, and store should mimic the domain model, the data model. And I'm going to get this example to talk about the next mistake, the next pattern, whatever. That is, you might be saying, okay, now you have your footer, you said that it's better now, and it is, but what if your store state changes? So, your store structure. You'll end up fixing the footer and breaking the other, and then you change the store again, and then you have to fix the footer. And imagine we had this store, and user.email, it looks fine in our footer. So, user.email, it's fine. But then, as I said, you change your store state, and then the email is not in the root anymore. So it's like user.contact.email, and it is fine. You're developing this app on your own, and just you know you were accessing the footer to run the email. So you go there and change user.contact.email. Okay, it's fine. But then, like, you hire one more developer, they start messing with the store, changing the store structure, and then this is going to break. And so the lesson to get from here is to use selectors. And what are selectors in the Redux React code? Selectors are no more than getters. So when we create a getter, we're trying to abstract the state that is behind it. So here with Redux, we normally use this library that is reselect. It's a very small library, like 2 bytes. And the best thing it does is memorization. So it's kind of caches your request. So if you ask for the same value 2 times with the same props, it will just give you the value instead of doing calculations. So selectors, this is the syntax, but what matters here is the syntax. Is that you base your components in abstractions. So you base your components in this email selector. And if you change your store structure and you put your email somewhere, you can go there, change the getter, and it works. And all your app would work in the same. So here it's like try not to couple components with store structure, because your store is going to change, and then lots of components will break. You'll probably notice because you have tests, but yeah, sometimes it's not that linear. And have memorize the selector. So you can create these selectors by hand, so just writing them, but try to be aware that if you write them by hand, you have to check, because sometimes accessing the selector many times, you might be doing like calculations that are not needed. So, to the next and final point, like it's duplicate reducer logic. So if you have written React or Redux apps, you know what's like a reducer is the place where you define your state mutations. So here we're defining, imagine this is a view counter, and in a counter you can increment or decrement it. And here we have these 2 actions. These 2 actions can be emitted by components. So a component says, I want to decrement this counter, or I want to increment this counter. And what it does, it gets the previous state and increments it, or decrements it. And so it is simple. But then, it can be a counter, but it can be an AJAX request. And there are things that always work the same way. And then, you start creating a people counter. And then this people counter, it's a counter, so it just increments or decrements. And you start duplicating code. Because, that's just how it makes it, because it's simpler, and people don't think about reducers as functions, or I didn't thought of it when I was writing this. But then your store will look like this. So you have a view counter and a people counter, and it is fine. And then you want to add more. But reducers are simple functions. So we are in JavaScript, so we have higher order functions or higher order reducers. There is no more than a function that can configure other function. So my possible solution for this would be a function that is called create counter reducer, and you just pass the name, the state, and the action, and this function knows how to create reducers that know how to increment and decrement counters. So now you have this logic that knows how to create counters. And as I said, it would be more useful if it were an AJAX request. So when you have an AJAX request, you have to start the request, and then you get a response back or an error. And for this, if you don't use higher order reducers, you'll probably end up creating action names that are not coherent, and you'll probably handle them in different ways, and you'll probably write lots of duplicate logic. So think of the reducers as a function, because that's what they are. So in the end, instead of using that thing 3 times, you use the same function, you just send parameters in. And then, to recap, do not reuse reducer code and reuse logic and enforce namespace in code.